Alright, hello everyone and welcome to this class. And in this class we are going to be solving some problems that are related to our first class. And the first problem here, first of all, what we need to know is to know our formula. We know that Q is equal to NE, right? Where Q is the charge and N is the number of electrons and E is the electron charge. And we also know that Z, right, atomic number Z, the number of protons and neutrons. And how we add, we know that charges are static, but when those charges begin to flow in the conductor, it is now called current. So current is denoted by I, is equal to the change in charge, that is the Q, over the time taken. For simplicity, we can write current is equal to Q over T, right? So the unit for current is in amps, but sometimes it can be given in coulomb per second. Alright, so let's get started. Example 1.1, I have 1.1 here. It says that the charge on a particle is 2 times 10 raised to power minus 4. Determine the charge quantum number. Now, they say the charge Q is equal to what? 2 times 10 raised to power minus 4 coulombs. Now they say determine the charge quantum number, that is the number of the electron, which is unknown, and we know that E is equal to 1.602 times 10 raised to power minus 19 coulombs, right? So from our expression we know that Q is equal to NE, and we have Q, we have E, we make N subject of formula, N becomes Q over E, right? And this becomes 2 times 10 raised to power minus 4 over E is 1.602 times 10 raised to power 19. 10 raised to power 19. Sorry. Okay. And if we do that, 10 raised to power 19. If we do that, we have, press your calculator, we have 1.25 times 10 raised to power 15. So, have 1.25 times 10 raised to power 15 electrons. That's the answer. Let's go to the next question here. The next question here, example 1.2, says lightning occurs when there is a flow of electric charge between the ground and thunderstorm. The maximum rate of flow in a lightning bolt is about 20,000 coulombs per second. This lasts for 100 microseconds or less, right? Okay. How much charge between the ground and the cloud in this time, and how many numbers of electrons? Now, what you are given is that the maximum rate of charge flow in the lightning bolt is 20,000. I told you that when current begin to flow, when charges begin to flow, it's now called electric current, right? So, which means that the rate of flow of this charge is 20,000. So that is 20,000 C over S. And the rate of flow of charges is also called what? Current. So that means that I is equal to what? 20,000 C over S. And from our formula, we know that I is equal to what? Q over what? Over T. Right? Okay. So that implies that 20 is equal to what? Q over what? Over T. And Q here, are we there? Q here is unknown, right? Because Q is what we are looking for. So that is Q. But what of the time? The time is 100 nanoseconds, right? No, 100 microseconds. So that will be 100 times 10 raised to power minus 6, because micro is 10 raised to power minus 6, right? Okay. So if we make Q the subject of formula, Q becomes 20,000, right, times 100 times 10 raised to power minus 6. And if you press your calculator, or if you solve it using simple mathematics, we have Q to be equal to 2 coulombs. That's the answer. Very, very simple. Now, the next question here is, how many electrons flow during this time? Now, what we are looking for here, since they say how many, this literally means we are looking for the numbers of electrons, right? And we know that Q is equal to NE. We have Q here. Q is equal to 2C. N is unknown, and E is the electron volt. And when we make N the subject of formula, it becomes Q, either capital Q or small letter Q, or Q, not Q. So this is, now Q is what? 2, right? And E is electron charge, 10 raised to power 19. Okay, the space now allowing, okay. So N will be equal to, when you press solve that, that will be what? 1.25 times 10 raised to power 19 electrons. So the number of electrons is 1.25 times 10 raised to power 19. You can approximate it because you see charges are in whole number. So if you like, you can approximate it. So that would be what? 1 times 10 raised to power 19 electrons. So that's the answer.